I did want to go over some of the code that we are providing for you to help you get started, right? So for instance, a couple of things. If the user class that we looked at last week, we modified it just to show you. All the code that I'm showing you is under a particular branch. If you go to your specific the GitHub for your particular section, and if you go down to branches, there will be a branch called assignment 4. Okay, if you go in there, there'll be quite a few commits that if you read them in reverse order, you can see my history as I was creating these, and it can give you an idea of how is that you can go about creating your own. Right. So, for instance, if we go back to on the 25th, that's the code that we provided here in the lecture. But for instance, here here's a couple of things that would show the relationship between a user and a review. Right? If you have a user, so user 1, creates a review for user 2. Right, so this writes a review saying something about a provider. Maybe this is a customer or client reviewing some service provider, some other user. Yes? Right. And as a class diagram, you probably capture it as this is the user, right? Here's a review, right? And there's 2 associations, right? Saying that the user has created many reviews for some other user. So here we've captured that. Let's take a look at it, how it was implemented. Let's look at the review data model. The review data model is very simple. It just has a title and the actual review that you're going to write about somebody. And notice that it's just a plain Java object. There's nothing special about it, other than that has been annotated as an entity. Right? Nothing spectacular about that. And so here's where it starts to get interesting. Here's where the relationship between the user and the review, we might capture this relationship. So for instance, in the review, there's going to be a pointer that says who was the reviewer. I need to know who the reviewer is and who did they review. Right? Just like maybe an email, right? We need to see who's to and from, right? So same thing here. So the reviewer has references to both who wrote the review and who was it about. On the user side, you would have links to things that I've said about somebody and what other folks are saying about me. Right? I could say all the reviews of me, what people are reviewing me, and all the reviews that I've written about other folks. Yes? Right? So this is only Java, notice, right? This is only Java, and this would only work in memory, right? It would only exist while the computer's running. We need to be able to persist this, right? And write this to a database. Okay? So how do we do that? Well, what we can do is to create a many-to-many or many-to-one relationship. For instance, here in the review side, on the review side, we can specify that we're going to participate. This is the review that we have. There's one user who's going to write lots of reviews. And that we're going to also have one user is going to have many reviews. So if you give me the user, I can tell you their reviews, or that they wrote, or the reviews that somebody wrote about them. Yes? Right? So these are the reviews, and this is what we're displaying here. We're saying that the user that I have is in a many-to-one relationship. So we are on the many side. So this review object is on the many side of a one-to-many relationship. That's why it's written backwards, many-to-one. We are on the many side, star. We are on the many side of the relationship. Okay? And we're saying that we're going to. This is going to create for us a table that's going to join these two tables. Right? So, for instance, let's see the user on the user side. On the user side, we say that these reviews, the reviews that somebody wrote about me, and the reviews that I'm writing about somebody else, right? We are on the one side of a one-to-many relationship. We're on the one side of a one-to-many relationship. That's exactly what we're doing here. We're the same annotations that we use in a class diagram. We can readily implement them in Java. One thing that you should remember, that these objects, at some point, right, they live in a database. Yes, they live in a database. Eventually, they can live in memory as instances temporarily. Yes, so they have two representations. They have a representation permanently in a database, and they have a temporary or transient representation in memory. Yes, okay. They can also have a representation on the client side, whoever's asking for this data through the web services, correct? Right? And so there has to be just like the JPA handles the mapping between the relational database and the mapping in the object, they're the ORM, the object relational mapping mechanism that convert from a relational database to an object representation. There's also a mapping between that object representation in memory and JSON. Right, that you're querying through the RESTful services, correct? Well, there's a problem in that conversion of going from JSON to memory, in that if I start here at the user and I try to then convert this is going to be an array, right? So a user has many reviews. That's going to be an array, but then when I get to the converter is going to create this as an object, a user object. We create this as a user object. It's going to get all the reviews. All the reviews are going to be an array. And as it gets, and it tries to convert the first object, and it'll convert the title. It'll convert the actual review as a string. But it'll get to the user object. See, that's going to try and convert that user object. And that user object, it's what? It's this object over here. It's the original user object. You see that? So basically, it's going to try and copy this whole thing in here again, right? And when it gets, and that's going to have another user in there, which is the same object outside. So it's going to get into an infinite loop trying to convert this. Yes? So JSON ignore tells the converter to stop. Do not try to convert this, right? Otherwise, you're going to get into an infinite loop. Right? So JSON ignore stops the converter when it tries to convert it into a JSON. Do not convert this. These are the create. This is the review class table. Right, here's the table. Notice that it has foreign keys pointing to the users that who wrote this review and who was it about. Who wrote it and who is it reviewing, plus all the titles and the review. Also, here's an example of saying that I wrote a review. That's the title of the review, and user 1 was reviewing user 2. Yes. The review repository is it's empty. It doesn't have any. It'll use any of the default Finder methods. If I need to create any queries, they will go in there. I did write a couple. I wrote the find all reviews, which is in the repository. This would be select review from reviews from the review table. And I wrote the service that allows me to expose all the reviews, that allows me to retrieve all the reviews. So this is a dependency that you might need to consider, because some folks are going to be writing the data model and some folks are going to be writing a RESTful service. Yes. So there you're going to have some dependencies. So you have to be careful. You might want to do is instead of only working on the Java data model or only working on the REST, what you could do, you could break it up differently. You say, I'll work on the well, one person can work on the data model, but if I need a particular CRUD operation in the repository, instead of waiting for someone else to write that query in the repository, right? Me as the owner of the RESTful service, I might take that myself. I'll say, oh, I'll go in, and I need this finder method instead of waiting for this other folk. Right? I'll go in and write it myself, write the query myself. Make sense? So that might be a nice way of splitting it up that way. Find review by ID. So here's another query: find review by ID, and then the exposing of that query. Update, delete. Okay. How about some of the new data models for this particular sprint? Here's the frequently asked questions. Right, so the title of the question itself. So nothing new here, right? Something trivial like we've built already. And then here's the relationship between a user having answered different questions. So for instance, in the frequently asked questions, I added the fact that this is the user who answered these questions. Right? These are the answers. Right? And this is the person who answered those questions. I also have a reference to the question itself. Right? I have a reference to the question itself. You have a question? I'm sorry? No, not quiz. Is that okay? I'm sorry. Yeah, no quiz. Doesn't mean you have to leave. Yeah, so we have the user here. There's a one-to-many between the two. So notice that here we have on the answers we're saying that we are on the many side of a one-to-many relationship, meaning one user will have many answers. Right? So this will be like this. So we have one. So these are the frequently asked answers. So it's a one-to-many. So one user is going to answer many questions. So one provider is going to answer many questions, and that particular answer will be for a particular frequently the questions FAQ. There'll be one answer will have one question. So that's the answer to that particular question. Right? Sorry. Let's see. Link the FAQ to the answers. So this is the answers connected to the questions. Okay. What else? Let's see. We have a. Oh, this one's interesting. Transient. So transient. Where is it? Transient. So typically, when you add new fields to an entity class, those are automatically mapped to some field in the table. Yes? But sometimes you want a field that that you don't want to store in the database. You only want it to exist in memory, right? Maybe a field that you want to calculate on the fly, right? Maybe you have a field A and B that are stored in the database, but C is adding A plus B. Yes? It would make no sense to store C also in the database, since you can always calculate C in terms of A and B. Make sense? Right, so you'd store A and B, but don't store C, because C you can calculate it. Make sense? So what you would do is that you would make C transient. You would make C transient, and the value, the get, would be the adding of A and B, which are actually in the database. So in this case, this is what I use transient for the answer, so that in the answer, when I ask the user, give me all your answers, I would like to also see all the original question, right? The original question that was in there. But the question is where? The question is over here, right? I would need to do some kind of join and go fetch the original question and join it with the answer to display it. An easy way of doing it is to declare transient. Right? It says, okay, I want the original question. What was the original question? Well, I know there's a relationship between the answer and the question, so I can retrieve the question and just print out the question. So this one won't be stored. It won't be stored as a field in the answer, right? Because it's already stored here. It makes no sense to duplicate it again as the answer. Make sense? Right? So I can fetch the original question and include it as part of the answer to the user. Okay. Source category. Anyway, take a look at the code that I provide for services and categories on how to relate the two, and this should help you to get going, right, and implement the classes. All right. Let me see.